Hello, future engineers, subscribers, viewers, and students. Here is a video in statics. This video is about solutions to problems given as quiz problems in my different classes in statics from the university where I teach statics. I hope that through this video, all viewers, subscribers will be able to enhance their skills in statics. So here is the problem. Determine the resultant of the three concurrent forces, of which two are shown. The coordinates of point A is at at 2, -1, 5, while B at -3, 2, 4 meters. The third force with magnitude 650 newtons has direction angles of theta x, theta y 128 degrees and theta z 42 degrees. By the way, the third uh, force is not shown here, but the direction cosines are known. So remember that the force in vector form would be magnitude of the force, quantity cosine theta xi plus cosine theta yj plus cosine theta zk if expressed in vector form. So here's the given figure. First, for F1 with magnitude 620 newtons, it is directed from point A to point B. So let's compute the distance between A and B. So it should be coordinates of B minus coordinates of A, terminal minus initial. So for distance AB, it is -3 minus 2 square root of quantity -3 minus 2 square plus 2 minus -1, so 2 plus 1 square plus quantity 4 minus 5 square. So distance AB can now be computed and it is equal to square root of 35 meters. So that is distance from A to B. The force in vector form is equal to magnitude 620 for F1 in vector form. 620 divided by distance times quantity delta xi plus delta yj plus delta zk, where delta x is simply this value here, -5, delta y 2 plus 1, 3, and delta z is 4 minus 5, so it is -1. So again, F1 is equal to 620 over square root of 35, quantity -5i plus 3j plus -1k. So simplifying, distributing using your calculator, F1 in vector form is equal to -524.0i plus 314.4j minus 104.8k. Now for F2, uh, this is given the angle that F2 makes with the y-axis, that is cosine, that is theta y, is 90 degrees minus 32, so it is 58 degrees. So F2y is equal to 480 cosine of 58 degrees. Another way is F2y is 480 sine of 32, which is this opposite leg of 32 of this right triangle. So F2 is equal to, we compute this component first. This is hypotenuse 480 cosine of 32 as shown in this figure. So F2 is 480 cosine 32, which is this times cosine of 20i. The x component of F2 is directed to the right. So it is this orange magnitude of this orange shadow of F2, which is 480 cosine 32. Then since F2x is adjacent to this 20-degree angle, this serves as the hypotenuse of another right triangle, and that adjacent leg is 480 cosine 32 times cosine of 20i. F2y is simply 480 sine of 32 or 480 cosine of 58 degrees as mentioned earlier. Then the z component is also positive in this direction. It is 480 cosine 32, then it is opposite to 20, so sine of 20. 480 cosine 32 sine of 20 degrees. So simplifying, that is 382.5i plus 254.4j plus 139.2k newtons. Finally, for the third force F3 in vector form, it is magnitude 650 quantity cosine theta xi plus cosine theta yj plus cosine theta zk. So substituting F3 is 650 quantity cosine of 68 degrees I cos plus cosine 128 degrees j plus cosine of 42 degrees k. Using your calculator and simplifying, F3 is equal to 243.5i minus 400.2j plus 483.0k. So the resultant is in vector form. The vector sum is r equals f1 plus f2 plus ft. These are vectors. So f1 is simply the f1 plus f2 plus f3 in vector form would be sum of corresponding components. So for I, it is negative 524 plus 382.5 plus 243.5. Then I. For J, 314.4 plus 254.4 minus 400.2 quantity J. For K, quantity negative 104.8 plus 139.2 plus 483K, and close in newtons. So that would be 102.0 I plus 168.6 J plus 517.4 K. So that's the solution to this problem, and I hope that you find it simple, especially for my students. That's the solution. That's as simple as this solution here.